Today we're starting the third unit of the year, which is solving quadratic equations. Our first lesson is solving quadratics by factoring. So there's 4 methods that we're going to be covering. There's solving by factoring, by square roots, completing the square, and quadratic formula. Today we're just doing the first of those 4 methods. And again, it's on factoring. So if you forgot how to factor an equation, which you may have because it's been a little while since we've done that, then on my website there's 3 other videos explaining how to factor. If I swipe up, here's my website under Unit 3. Right at the top of the page you see 3 videos for reviewing factoring. Check those out, they're definitely helpful, and yeah, you need to make sure you know how to do them. If you already remember how to factor, or if you can watch this video and figure it out from there, then that's fine too. All right, so quick review. Factoring is rewriting an expression as a product of its factors. You can factor many quadratic expressions into products of 2 binomials. All right, to quickly review a factoring guide. The first step when you are factoring is to always check for a GCF. So a GCF stands for the greatest common factor, and a common factor is when you have a term that can be divided out of every term in the expression. For example, if we had 4x plus 16, both 4x and 16 can be divided by a value of 4. That means our greatest common factor is 4. And when we divide that out of the first term, we're left with just x, because 4x divided by 4 would eliminate your value of 4, leaving you with just x. And if we divide 16 by 4, we're left with 4. So this here would be your factored expression after taking out a GCF. All right, so yeah, first step is if there's a GCF, and then with that, you need to check to see is there a leading coefficient of -1. If there's a leading coefficient of -1, then you need to factor that out. And we do go over a couple of examples like this, so I'll point them out when we get to them on this page. And then the other point that we need to talk about is the fact that we will have 3 terms in most of our functions. So that would be in the form of a times x squared plus bx plus c. And this is standard form. And that's what you would need to factor. That's called factoring in quadratic form, or factoring a quadratic. So a few notes here. We need to know the difference between an expression or an equation. And if you watched the 3 previous videos on factoring review, those are all expressions. This entire note sheet is going to be equations. So just to quickly sum this up, we would say that an expression is a phrase, while an equation would be a sentence. So what we mean by that is the fact that a phrase is obviously just a phrase, while a sentence is complete. It has a starting point and an ending point. That's the difference between an expression and an equation. So to go on from there, you can simplify an expression where you can solve an equation. An expression has no relation sign, while an equation has an equal sign. This is a huge one right here. That's really the biggest way you're going to be able to tell if you have an expression versus an equation. So to go off of those two factors, let's take a look. If we had x plus 2, that's an expression. If we had x plus 2 is equal to 6, that's an equation. Notice the difference between these two. One of them has an equal sign, one of them does not. If we had an expression such as 2x, that's just the expression, but 2x is equal to 20, that's an equation. And both of these have an equal sign. All right, the zero product property says that for real numbers a and b, if a times b equals 0, then either a equals 0 or b equals 0. The first example is going to be the most basic example for you. This expression is already factored. So if that's already factored, the zero product property just says that one of these factors must equal 0. So if that's the case, if one of these factors has to equal 0, set each one of these factors equal to 0 and solve for x. So if we have x minus 6 equals 0, we would add 6 to both sides. That gives us our solution of x equals 6. For the next one, if x plus 2 equals 0, subtract 2 from both sides. That gives us the solution of x equals negative 2. These are your answers. You can either leave them written like that, or you can list them as x equals negative 2, 6. That means if you substitute either one of these values back into the original function, you're going to get a 0 either here, or you're going to get a 0 here. But either way, if one of these is equal to 0, then the entire function will equal 0. So you can check your work. Just check to make sure. If I substitute negative 2 in, is that going to create a 0? Yes, it is. That's what you want to happen. And for the rest of these examples, you are going to have to factor the quadratic. So that means you're going to have to use the methods gone over on the review sheet. For this one here, we need to factor x squared minus 9x plus 18. Recall that standard form is ax squared plus bx plus c, and we want to find what a times c is. So in this example, our a value is 1 and our c value is 18. So a times c is 18. Now we need two factors that multiply to equal 18 and the same two factors that add to equal our b term, which in this example is negative 9. So these have to be the same factor. And I would say in this case that we would have two factors that are negative 6 and negative 3. Negative 6 and negative 3 multiply to equal 18. Negative 6 plus negative 3 add to equal 9. Now we rewrite the middle term. That's all we do in this next step. we have x squared. Instead of writing 9x, we're going to use our two factors. We're going to write this as negative 6x minus 3x plus 18 equals 0. So all I did was rewrite what I highlighted in green as negative 9x. I rewrote that as negative 6x minus 3x. Group the first two terms, group the last two terms. The GCF of the first group is x, left over is x minus 6. That means if I divide each of these terms by x, I am left with x minus 6. The GCF of the second group always matches that sign right there. So in this case, the GCF is going to be negative 3. If I divide both factors by negative 3, I'm left with x minus 6. And this is equal to 0. I need these two factors to be the same. If they are not the same, then I did something wrong. I write my final answer as x minus 3. Those values come from here and here. X minus 3 times x minus 6. And that value comes from here and here. This is equal to 0. Now we're at the same spot that we were at on the first problem, but the first problem already gave you this step. So we have two factors. We need to set each factor equal to 0 and solve. We have x minus 3 equals 0. X cannot equal 3. I'm sorry, x equals 3. I don't know why I said that. X equals 3. We get that because we added 3 to both sides. And x minus 6 equals 0. Add 6 to both sides, and we get x equals 6. Our final answer, x equals 3 or 6. When I make a list like this, like what I just highlighted, the smallest number always comes first. All right, number 2, we have 2x squared minus 8x minus 42 equals 0. We have a GCF. We have a common factor in all terms. That common factor is 2. If I factor out a GCF of 2, I'm left with x squared minus 4x minus 21. Now I need to factor this expression. A times c is equal to negative 21. I need to know what two factors multiply to equal negative 21 and the same two factors that add to equal negative 4. That would be negative 7, positive 3. I'm going to rewrite my expression as x squared minus 7x plus 3x minus 21. At this point, all I did was rewrite negative 4x as negative 7x plus 3x, and that came from right here. Group my first two, group my last two terms. GCF of the first group is x. If I was to divide an x out, I'm left with x minus 7. GCF of the second group is 3. Left over is x minus 7. I'm going to group these. My first factor will be x plus 3. My last factor will be x minus 7. This is equal to 0. Also, don't forget that you started with the GCF, so that is in your factored answer. However, when you set your factors equal to 0, you set every term equal to 0. If we took 2 and set that equal to 0, that does not make any sense. 2 cannot be equal to 0, so that is not part of your answer. We have x plus 3. This can be equal to 0, and it would give you an answer of negative 3. And we have x minus 7, which would give you an answer of 7. Listing from smallest to largest, we have -3 and 7 as our answers. And once again, you can check your work. You can just substitute those values back into your original expression, and you make sure you get a 0 as your answer. Number 4. So number 4 has the negative sign, like I mentioned when we were first talking at the top of the notes. Right here. So if there's a leading coefficient of -1, and I said we'll get to that later in the notes. So here it is. The first thing I recognize, well, is that I have that -x² plus 7x. I need to move 12 to this side of the equal sign. I need them to all be together. So subtract 12 from both sides, I end up with -12. Now I have to take care of that negative sign. I'm going to factor out a value of -1, which is the same as dividing every term by -1. That leaves me with x² minus 7x plus 12, and this is equal to 0. And now I'm going to factor that expression. All right, I need what two factors that multiply to equal a times c, which is 1 times 12, or 12, and the same two factors that add to equal -7. That would be -4, -3. We have x² minus 4x minus 3x plus 12. Group the first two, group the last two terms. GCF of the first group is x, left over is x minus 4. GCF of the second group is -3, always matches that sign. Left over is x minus 4. My GCFs form a factor of x minus 3 and x minus 4. This is equal to 0. Don't forget your common factor of -1. Set each factor equal to 0. -1 equals 0. That's not going to happen. That doesn't make any sense. X minus 3 equals 0. X equals 3. X minus 4 equals 0. X equals 4. X equals 3 or 4. Okay, and for these last three examples, I'm just going to do the workout. You can follow along, and you can look at my notes too, either way. But I'm just going to do these without talking.